2, and you also have an x subtract 6 there. Woo! Now, can anyone tell me, at this point right now, before I even cancel, I do see someone canceling, what would you say x cannot be?
6.
That's my domain. X cannot be at this point, what?
It can be 3.
Positive 3,
Negative 2.
negative 2, positive 6. Cannot let x be those. Now, if I go further and simplify, and see now why maybe x cannot be one of those immediately, because I think these two will cancel, and leaves me now to consider this remaining part. There it is, simplified. Now, can someone tell me, maybe out of order, based on your handout, since these two cancel, what does that tell me also is happening?
There's a hole.
There's going to be a hole on the graph. So guys, I'm going to pick up right now, I know it's out of order. Number 2, I'm going to quickly identify where the hole is. There's a hole on the graph. It depends on what factor canceled. My factor was x subtract 6, so the fastest way to find where that hole is going to be located, solve that factor. In other words, z equals 0, solve it. And of course, I need a full point since we're talking about a hole there. So the x is 6. The y will be, just go quickly back here maybe and plug in 6 in your simplified version and see what number might come out, maybe a crazy number. So guys, if I go back and put in 6 here in my function, I'm going to end up with, let me do the math up here, 3 times 6. 6 plus 4 is 10. Just doing a little math here. 6 subtract 3 is 3. And 6 plus 2 is 8. 3's will cancel. Run some math. I could cancel. Now, this is me, the way I'm going to do it. Oh, in fact, let's do it this way. That's 60 over 8. Lots of ways to do this. And guys, 60 over 8, someone help me out. Divide 8 into 60, what is that? 7 and 1/2? Is it 1/2? I think. Is it? 60 divided by 8? Is that 7 and 1/2? Yes?
15 over 2.
Therefore, if it is, this is the y coordinate. I'm like, oh, what if I get to it? 6 comma 7.5. Yes?
Wait, I'm sorry, but where did you get the 6 from?
You take the factor that canceled,
Yeah.
set equal to 0, and solve it.
Okay. Thank you.
Okay, you take that factor that canceled, and solve it. Absolutely. So guys, if all that's right, now I know where the hole's located on the graph. Now, number 3, Aiden, back to you. I did that because quickly I recognized there's a hole here.
Now name the intercepts.
Now, the intercepts?
Yeah.
Okay, let's find the x-intercepts, guys. And I think I pointed out last week, a quick way to find the x-intercepts is we're supposed to set the function equal to 0. But since this is a rational function, you're going to set the numerator equal to 0. That's what it comes down to. All kinds of little tricks to play here. Set the numerator equal to 0. Solve it. So I'm going to end up with 0, a negative 4. I like ordered pairs myself. So these are my x-intercepts. 0 and negative 4. To find the y-intercept, as always, go back, replace the x's with 0. In other words, find r of 0. And guys, if you do it here, or back at the very beginning, I think you're going to end up with 0, which might tell you should have, because I see a 0, 0 x-intercept. Now, here's the part you got to pay attention to on the quiz on Wednesday. These have so many parts to them. If you mess up and got the hole in the wrong place, you've got the vertical asymptote in the wrong place, that's going to throw the graph off. That's why I'm just giving you one problem to do. You've got a good 30 minutes to do it. One little mistake on this is going to throw that graph off. Aiden, I got the intercept out of the way. Tell me what number 4 was.
Determine the vertical asymptote.
There you go. And guys, does anyone recall how to find those vertical lines? They're called vertical asymptotes fairly quickly. Does anyone recall?
Where the domain
more, tell me more.
Where the.
I'll give you a hint, look at the red.
Where the x should not be equal to.
Okay, set the denominator equal to 0. I may have said that on the handout. Now, Aiden, read and see if I said that. Define the vertical
define-
asymptotes.
Set denominator equal to 0.
Okay, so set that denominator equal to 0, which is right here. And solve it, no problem. You're going to end up with a vertical asymptote when I finally get to the grid of 3 and -2, and that's done. Number 5. Aiden, was that horizontal asymptote next?
Yeah, the horizontal asymptote. Determine the horizontal asymptote of any of the graph.
Okay, now, that's going to describe the end behavior. Now, we'll give you a shortcut. Keep in mind what this says. If you walk in here on Wednesday, and you're doing your problem here, and they're asking for the horizontal asymptote, and you check out your function, please tell me, did I start out with these highest exponents, called the degree, of the numerator and denominator being the same number? Are they identical? Do both of them have a degree of 2? Is it the highest exponent? That's the best case in the world, because your horizontal asymptote will be merely those coefficients, 3/1. A little shortcut. So we'll go up to 3 when I finally get to the grid and draw a horizontal line. That's going to act as an asymptote. By the way, guys, please, if I took a vote right now, I'm sure you would say, Professor, please give us one on Wednesday where these match up. Because the shortcut is the horizontal asymptote is located with, when you compare this coefficient to this coefficient, 3/1. Now, did I, Aiden, say to do something with that horizontal asymptote before we leave it? Was there further down something else concerning this?
With that asymptote.
You says as x is approaching negative infinity.
Oh, beautiful, that's something else. We'll go a little further.
Determine the oblique asymptote.
Okay, no, right. Did I ask for maybe a crossover point?
No.
Did I mention anything about a crossover point?
Is it possible for the graph to?
Oh yeah, yeah. Is it possible for the graph to intersect / cross its horizontal asymptote?
There you go. Sometimes the graph will cross over the horizontal asymptote. Guys, to find it, if you want to find what they have in common, set the horizontal asymptote equal to this function. Now, if you want to set it equal to this, which might be easier, and see, and then do your math and try to find what do they have in common. So set the horizontal asymptote equal to the original function, or the simplified version may be easier for you. Try to solve it. If you can't solve it, there is no crossover point. If you can solve it, my graph is going to cross over the horizontal asymptote. Guys, I know these cross out. I'm going to go back to this form. Left over 3x squared plus I think it's 12x over x squared, subtract x, subtract 6. I'll use that for my 3 equal to that. And try to solve that the best way I can. I would suggest you just quickly cross multiply. If you do, I'm running out of space already, you're going to end up with 3x squared minus 3x, subtract 18, and cross multiplication on the other end will give me this, 3x squared plus 12x. Let me step back, guys, and see if you guys agree. Agree? All I do is just cross multiply here. Yes? No? Can you guys see that? Up there? Can you see it? Even this may be in the way. Can you see it? Everyone? Okay. To solve this, guys, the 3x squareds drop out. Now, is it going to be solvable? If it is, I'll solve it. If I can solve this simple equation, I'm going to do mine like this. I'm going to move the 3x over and write this as negative 18 is equal to combined 15x. Divide by 15, there's a negative 18 over 15. Let's reduce that down by 3. A negative 6 over 5. So this is gonna cross. It's gonna cross over when x is -6/5. So the crossover point has for the x -6/5. Now watch carefully. So you set the horizontal asymptote's value equal to the function. And find they have something in common. Can you solve it? Can anyone tell me what the y coordinate is? I know what the x coordinate is. We solved for the x. The x, if I have no mistake, is this strange number. Can anyone tell me what the y coordinate is for that crossover point? Shame on you. It's supposed to cross over the horizontal asymptote. Where's the horizontal asymptote located?
3.
3. Y is equal to 3. We discovered that earlier back here somewhere in all this work. In fact, right here next to me. Y is 3. Okay, now this one's crazy. Now, 8. Tell me what may happen on my next exercise when I show you another example. Tell the class what else might happen. What else did I have on that handout afterwards?
Determine the
The
oblique
behavior.
Oblique. And I have not discussed an oblique at all. I thought I better do this one first. Now, can you imagine you walk in your quiz and look at all the board space it took me, and I don't have the graph yet. They said sketch. I don't even have the sketch. I just have all the information about the sketch. So guys, we're gonna try to put this together the best we can. Got some good markers that will hold up for me hopefully. And we'll see what happens here. Get the grid ready for us. Guys, here's the grid. Now, if I were a beginning student and may have never seen a rational function in my life, and all of a sudden, you say, Professor, you're trying to get a picture of, a graph of what this looks like. We'll see what it does look like. And we're gonna fit all these pieces together. Guys, on the grid, I'm gonna start out with the x-intercepts. We'll put those in red. The x-intercepts came out to be, where are they? 0, 0, and -4, 0. Let me do that right here. -4, 3. Label these. I'll step out of your way here. So guys, again, x-intercepts are these. Y-intercept, 0, 0. Where's the y? No, where was the y-intercept? Y-intercept was 0, 0. It's here. Okay, -4, 0. Back here. Y-intercept, 0, 0. Now we're good. Got those out of the way. Those are the x and y intercepts. Now I've got so much going on here. Vertical asymptotes. Now there's a vertical asymptote located at 3. So I'd go directly to 3. Let's see if this green marker will hold it up for me. And show there's a vertical asymptote here. And also I think I found one. Let me try to find where I am. At -2. Let's go to a -2. Another vertical asymptote. You get partial credit for all this. Geez. Horizontal is up at 3. We're going to mark 3 up here. And since I'm trying to use different colors here, we try blue here for the horizontal. It's up here. I find a different marker. Now, it's up here. Something like this. That's my horizontal asymptote. Wow. So I've got two green vertical, one horizontal. I've got two intercepts, x-intercepts, and one y-intercept, of course. Are we ready to graph it? Do I have all the details on the grid at least? Now, how many sections to this graph are called discontinuous, disconnected? How many sections to this graph will I have? 3. Something to the left, something in between, and something to the right. Now, I've had some students in the past, but I don't think I would suggest this. Some students just go ahead and guess. They're saying, Professor, I think I can guess without plotting points what's happening on the left of that green vertical asymptote. Guys, on the left, you gotta pick that point up. Does anyone have an idea what it might look like to the left? You gotta pick up -4, and you gotta follow the green and the blue. So what might that piece over there look like? If you follow the blue, the green, and you pick up the red. Does anyone have an idea what it might look like at this point? Yes, go for it.
Maybe like a line or
Like this? Something like this?
Yeah, maybe.
Hang on now. That picks up -4. Does it follow that blue? Which it should. It should get closer and closer to that horizontal. That's why it's there. Does it also follow but it never touch the vertical? So that's why those asymptotes are there. They're acting as guides to that graph. So I got that out of the way. In between, yeah, at least I got a point to work with in between. It's here. Now, I can plot points. You can always form a table and plot points yourself and get a better idea of what that in-between part may look like. Does anyone have an idea of what it might look like with me just staring at that? And be very careful on this one. Yes?
So, we found that, the middle graph crosses over.
Okay, it's gonna cross over here at -1 1/5 up 3. Crossover point. So guys, if I go to a -1 1/5, I'm out here on this side. -1 1/5 up 3. I'm gonna say it's right here. That's my crossover point. Do you guys agree? -1 1/5, roughly up 3. So I got to pick up that point. I got to pick up my origin, which is an x-intercept, y-intercept, and follow my asymptotes. I don't think I have much choice. If you guys will agree. Must it look like that? And you can always plot points to make sure. Did it cross over the point? -6/5 and 3 had a crossover point and follows those asymptotes. Wow. Only one more piece left. Something to the right is happening. Guys, to the right, I have nothing to work with. Any guesses? I mean, I may have to plot a point myself. Is it up here?
Yeah,
Down here?
no.
Now, suppose I did this. Don't do it right now. Suppose I did not know, I didn't plot points. Suppose I said, well, Professor, this does what you said it should do. It follows this blue, and it follows the green. It follows those asymptotes. Why? It does follow the asymptotes, but why is it not there? Tell me.
Should it be the opposite from the?
Well, tell me why it's not there. Why should I erase this? Even though it does follow the asymptotes. What's wrong with it? Is it crossing the x-axis?
Yeah.
We don't have another x-intercept. We've already found the x-intercept. There is none out there. So I cannot use it, even though it was doing what we thought it should do. It can't be there. Let's pick up another x-intercept. So the only possibility would be up here with this. And that's your graph. Yes.
What about the hole?
Hang on. Yeah, there's your graph at this point. Gotcha. Now you say, Professor, hold on. my head's full of all this, it's gonna take me 30 minutes to do one problem. He says, Professor, don't forget, we had back here, because of this cancellation, we had, where is it, right here, a whole, look at it, out 6, up 7 1/2, which I gotta show. So guys, out 6, I gotta extend this on out, which I'll just do right here. You go out to 4, 5, 6, and show the best I can. It's supposed to be up at, what number was it? 7 1/2. So let me redraw this and make it look reasonable. So this might be doing something like this. And you can show me right here, Professor. I'll just go ahead and make that a hole there. I'll label it for you. And all the arithmetic is correct. I think it looks like that. Whew. Mr. Parker, remember doing these? Now, is the graph complete now? Is everything that we discovered? Lisa, look at all that work I did over there on the left to get to the right. Is everything there? I think.
Yeah.
Okay. Yes, go ahead.
Just double check, you got the Y value of the whole by plugging in R to 6, right?
Come again?
You got the Y value of the whole by just.
Plugging in. Just plugging in.
Okay.
That's
Do
right.
we need to write down the integer?
No, I'm gonna show you. Ask a few questions here. Now, first I'm gonna get the graph. Let's get the graph first. Now, guys, after you get the graph here, what's gonna make this a nice quiz is then all of a sudden I'm satisfied with that. That's a big chunk of the quiz right there, just to get that much done. Look how much time it took me to do that. Now, some questions on the side here would be, let's see if I can find a good marker that will work for me here. Okay, by observing the graph, please tell me first, how would you answer this question? Find the limit, well, these markers are out. Find the limit based on your graph. Oh, much better. The limit as x is approaching infinity of this function. Anyone tell me, based on the graph, be careful. As you walk this way forever, that's what this means. You're on the x-axis, and you're walking this way forever, and you're dragging that graph along with you. What's that graph doing as you walk this way and you drag it along with you? What's it doing? It's approaching 3. That's your limit. Let's try the other end. This is called end behavior. Number 2. Let's try to find the limit as x is approaching negative infinity of this function. Guys, this time you're on the x-axis down here. This time you're walking in this direction, the negative direction. You're pulling the graph along with you. The graph's up here. As you pull this along with you, what's it doing? It's approaching
Sorry,
3 again.
3.
It's underneath it this time. But is it approaching 3? That's the end behavior. Number 3. I'd like to find R at 2025, which you might think, oh no, he wants me to go back and replace all these x's by 2025 and crunch the number out. You don't have time for that. So way out there at 2025, now I stopped at 6 myself, way out here, 2025, your graph is approaching what? 3. This is close to 3. Guarantee you, if you have the time to go back and actually replace all those x's by 2025 and crunch it out, you'll get something close to 3. I bet if Mr. Park did it for us, it'd probably be 3 point something, 0001 or something. There. Okay? On the other side, you could also get close to what? 3 again, but this time maybe 2.9999 is beneath 3, but you're still close to 3. Number 4, let's find the limit as x is approaching, let's approach one of these asymptotes. Let's approach 3 from the right of this function. A little superscript with a positive sign. Lisa,
That would be.
Here's my, hang on now, here's my 3. It says stay on the right of it. So I'm gonna stay on the right, but I won't approach it. It says you're coming in, getting close to 3 on its right-hand side. As you get closer and closer to 3 on the right of it, what's my graph doing? Where is the graph? If you're staying on the right-hand side, where's my graph located? Is it up here? Is my graph up here to the right of 3? Is this a graph here? Is that to the right of 3? And what would you describe as I'm getting close to 3, what's that graph doing?
Infinity.
Infinity, it's rising through infinity. Number 5, let's try to find the limit. As x is approaching, let's try maybe -2 from the left.
Subscript. Oh, should be.
Absolutely, subscript from a negative sign. Guys, here's -2, and here I want you to stay on the left of it. So we know we're left and right, so on the left-hand side of -2 is this side. And you're coming in close to -2, but you're staying to the left of it.
Negative infinity.
What is that graph doing? Is it dropping down through negative infinity? So I can have questions like that. Woo! Now, if your instructor took a half an hour to graph this, that's why I'm giving you a good 30, 35 minutes. So don't walk out here and tell other people, oh, Brains is going to just give us one problem on the quiz. Where do you see that one problem? Look how much time it took here. Samantha.
So what if it's like, x is approaching in this case, like,
If x is approaching.
if it's approaching like 3 to the left side, though, like the opposite side?
Exactly. If you approach 3, here's the problem, Samantha. If you're approaching 3, I must tell you which side are you approaching. Are you approaching on the left of 3, or are you approaching on the right of 3?
So if in this case it's approaching.
They can change.
Yeah, but I'm saying in this case, if it's approaching from the left of 3, it's still going to negative infinity.
Yeah, we're asking to approach 3 from the left. I think asking to approach 3 from the right. This
Yeah.
one's 3 from the left. The answer would be negative infinity.
And if it was like 2 from the right, it'd be positive.
-2 from the right, beautiful, positive infinity. Absolutely. And all this, what the graph tells you. Darn, step back and look at it. Gee. I'm not gonna take too much more time. I got one more to do here. The next one's also gonna be a little tricky. Guys, we're okay with this? Rational functions. You got to turn to your textbook in that section and practice with some of these. Yes, go ahead.
So what does like the 3 of x mean exactly?
I don't see a 3 of x, I see an R.
I mean for like number 4 and 5 when you're talking about the whole thing.
You're approaching 3 from the right, you're just approaching, they want to know, as you get close to 3 in this function, what is my function getting close to? And we said it's getting large. So if you had the time, you could say, well, 3 to the right, Professor, you're talking about a number like 3.0001. That's to the right of 3, it's bigger than 3. You're saying, go back, put that in, if you have the time, replace all these x's about 3.0001, crunch this thing out, I bet you get a big number. And that's why it's represented as infinity. Okay, that's what the graph shows. Yeah, good question though. Okay, guys, I have only one more. Now, here's the concern. Whew. If these two do not match up. If these two do not match up. Now, I want to look at, we'll see, guys, I need to erase all this. Look at this. How much work it took to get to this point. Guys, any concerns here? Okay. Now, oh, by the way, did we had a hole in the graph.
Mm-hmm.
We also had a crossover point, didn't we?
Yeah.
And was that crossover point right there?
Yeah.
I didn't label it, but it came out to be something over in all this that.
Oh, it's right there.
Mike, this right here staring at me. This point, wasn't it?
Yeah.
Even though there was a crossover, a hole in the graph, vertical, horizontal, this thing had it all. Except Wait till you see the next one. Yes,
I had a question about the whole.
Go ahead.
graph. So, what exactly do we have to do to find it?
as soon as you see a cancellation, when you try to simplify the function, if you see something canceling right there,
Oh,
stop.
okay.
That says there's gonna be a hole on the graph.
So it's not like an asymptote, it's just.
No, beautiful. It's a hole. And that's because something canceled. So if you see a cancellation, you got a hole on the graph. Now, before I leave it, I'm glad you brought this up before I erase anything. Guys, tell me, was my domain, way back here, was the domain that? It was. It says X cannot be 3. Can someone tell me, based on what you see up here, why am I saying, don't let X be 3?
Asymptote.
There's a vertical asymptote located at 3. Don't let X be a -2. Why is that undefined? Was there another vertical asymptote on the graph at -2? And why do they throw in, or we throw in, don't let X be 6 either? What's happening at 6?
Hole.
There's a hole. So my graph cannot allow 3, -2, or 6. I've got 2 vertical asymptotes and a hole in the graph to work with. Wow. Now, we're gonna try one more. If this happens, let me find some space here. Okay, guys, here goes. After we get through rational functions, the rest of this will be, in that chapter 4 will be easy for us. So you guys, let's call this part 2. Sketch. And the one I want to sketch with us today is this one. You guys in the 4 o'clock session, I think, saw me get a start. Now watch carefully. Do your homework, practice with what the textbook gives you to practice with. Whew. See me at 4 o'clock, see me at 3 o'clock, see me at some time if you have difficulties. Now, first thing I notice on this one, when I check out the degree, highest exponent, numerator is 3. Denominator is 2. Darn it, they're not the same. It's not gonna be as easy as this one.
Yeah.
It's a little different, it's not the same. Now, he said, Professor, what happens, and well, you have to be very careful. If the one on top is exactly 1 larger, in my case, is the one on top 1 larger than the one on bottom when I examine these exponents? Yes, that tells me I have a different type of asymptote altogether, which I have not discussed yet. You have something that they call an oblique asymptote. Not horizontal, not vertical. Oh, we make it verticals, but no horizontal here. The horizontal is disappeared. You're going to have an oblique in its place. You cannot have both a horizontal and an oblique. This has an oblique, no horizontal. Now, oblique, some textbooks will call this. They'll use the word, there's a slant asymptote. And you say, Professor, what do you mean? It may be, look at this, a slanted line is acting as an asymptote. That's the strangest thing ever. A slanted line acting as an asymptote on your graph when you get ready to sketch it. Okay? Now, with that said though, here we go. I can simplify this. They got an X on top. X squared subtract 4. This factors further, difference of squares. No problem. Denominator, factors, much like this one over here. X subtract 3, X plus 2. Guys, you agree with all that so far? Is that true? Now, you guys were with me at 4 o'clock. Is this the same one we were
Yeah,
discussing right
that's
before we
the
left?
same,
Absolutely.
yeah.
Now, does something cancel? Something does cancel. The x plus 2's cancel out, which automatically tells me there's gonna be a hole in the graph. Take that factor, set it equal to 0, the one that canceled, and solve it for a start. So the hole's gonna be located at for the x -2. So that cancellation. Now what's the y? I need the entire point. I'm gonna go back and find r at -2. Now we're just plugging it in. I plug it into the simplified version, it's up to you though. Replace it by -2, I say a -2, help me out, -2 and a -4, which is what, 8, positive 8?
8.
And in my denominator, by -2, I see -2 subtract 3 is what, -5?
-5.
I'm gonna call this -8 here. So the hole on the graph, -2, 8 is. Wow. Let me step back and look at it. Okay. So far so good?
Isn't it -8 fifths?
What's it now?
-8 fifths?
I got a, what was it here?
You put -2, comma 8 fifths.
Did I have a negative over negative, the negative? Yeah, negative 8 fifths there. Samantha, that's what you're talking about?
Yeah.
Yeah. Okay, so far so good, guys? Whew. Now, 8, we're gonna jump into now those little steps there. Oblique, guys, let me get this out of the way first. You have never seen me show you, you may have known, Professor, how on earth am I going to come up with a line, not a horizontal asymptote, not just a single number like for a horizontal, a line that's acting as an asymptote when I know a line has an equation that looks like this. I gotta find what that mx plus b is. And that line, when I find it in that form, mx plus b, that's my slant oblique asymptote. Now guys, you have not seen me do it. Your textbook suggests this to find the oblique. Divide this out. That might be easier to go down here and divide here. So guys, we'll write this as, in my simplified version, I have x squared subtract 2x in the numerator. I don't know what the word is, so watch carefully. Over x subtract 3. That's what I have at this point down here. They're suggesting you divide that out. In other words, do long division. You'll say, Professor, I have not done long division since grade 3. You remember long division back in wherever? When you did long division? Now let me do this on the side here, just to point out. Darn, let's take off my time here. Here we go. If you were asked back in 3rd grade, I'll make this up very quickly, to divide that out. I'm gonna do that process here on this, shortly. What would you do first? Your brass could say, how many times will 25 go into 31? So, Professor, that's once. And then what'd you do?
Subtract.
Well, you're gonna multiply these two together.
Yeah, multiply.
You get 25. And then all of a sudden, you do what next?
Subtract.
You subtract, and you get 6. And bring down your next term, which is also a 6 in this case. Is that true, guys? And then you do it again if you can. Now, can you take 25 into 66?
Twice.
Well, how many times will that go? Twice? What's that, 50 right there? So twice here. 2 times 25 is 50. Leftover is how much?
16.
16. And what was that 16 known as back then? The remainder. And your teacher smiled and you smiled. You remember the long division process?
12.
Everyone smiled. Now, up here you had a quotient. My quotient is 12. Divisor, 25. Little vocabulary. Dividend, 316. Remainder, 16. Now you say, Professor, you want to do this from 3rd grade? You want to do this over here? I am. I'm over now on the side here. As I'm over here, we'll try to divide. Let's see if I can get this to work out for me. X subtract 3 into x squared subtract 2x. Now, can anyone tell me, based on third grade, what would you suggest I do first in the attempt to do that? I see hands going up. Okay. Start me out, Lisa.
Put the x, so,
Tell me, what did I do here? I took 25 into 31.
so then you multiply the x by
Well,
x.
no, I'm not gonna multiply anything yet. What would you do first?
How many times is
X
minus?
into, these markers are not working out tonight for me, I'm getting aggravated with you. X into, there we go, much better. X into x squared. That's where you start. Now guys, what would you say for x squared divided by x gives you? What is it, x? There's your start. What did I do after that when I got the 1 over here? Multiply these two together.
Multiply.
I got a 25. I'm gonna multiply these two together. But I'm gonna end up with x squared subtract what? 3x. What did I do next in my elementary school problem after I got to 25? I think I subtracted those two, didn't I? You got 6, so I'm gonna subtract these. And by the way, if you subtract here, it's more like an algebra problem.
That would be
Yeah,
negative
just
5.
merely change the signs. We'll just do it right like this. This and that. That's all you're doing, change the signs, you subtract. The first two terms drop out. I think if you put those x's together, please tell me, is it 1x?
Yeah.
Okay. So far, so good?
Yeah.
Now what did I do next? I think I took 25 into what, 66 if I could, and I got a 2. What are you gonna do here? Yes,
How many times x goes into x?
x into x. Will x go into x? Yes, one time, so you have another term up here. 1. And then take 1 times x subtract 3, you're going to end up with what? X subtract 3, subtract 1 more time, like I subtracted 50 over there and got 16, I'm going to subtract it in here, which merely says change my signs. Let's see if this will hold up for me. Change my signs here, x is canceled. Guys, I end up with a remainder of 3. Now, I'm checking this, you guys who have seen this before, it's looking good. Jeez. Now, what's my quotient in this one I just did? The quotient is what? X plus 1.
X plus 1.
Remainder is
3.
3. Divisor was x subtract 3.
Yeah.
The dividend was x squared subtract 2x. Guess what you get to do now? They're saying, please, from that long division, now write this out for me. And that's going to be my line, it's going to act as my oblique asymptote. Guys, in other words, you get to reject this down here. You have enough right here. Is that in the form of x plus b right now? If I just say x plus 1, where the slope is understood to be a 1, the y-intercept is understood to be a 1, could I say, based on that long division, you could quickly say, Professor, I could make it take that x plus b form right now.
Is that y will equal to 3 to the what?
You get to reject the 3 down there.
Why?
That remainder is going to drop out because you're left with already, this right here is automatically in that form of x plus b. That's all they want. By the way, can I do any more division, by the way, if I did try? Can I take x into 3? Is that possible? No. So I would have to stop there to begin with. I can't take x into 3, the process stops. A little strange, a little different. Yes?
Would that just be considered a remainder?
A remainder, which is going to have no effect on your x plus b. This top part right here is the x plus b.
That's all we care about.
That's all we care about. This is going to drop out for us. Wow. Okay, here we go, guys. Oblique, we got it. Now, to close this down, here we go. Other details that will help me to get a good graph here. Number 2, got the oblique out of the way by long division. Let's pick up the intercepts. And guys, I'm going to do this real quickly since you should know how to do this. X-intercept, guys, can someone tell me quickly, looking at this right here, where are my x-intercepts?
X equals 2.
tell me right quick, where are the x-intercepts?
0 and 2.
0 and 2, thank you. Right, like this. Absolutely. Can anyone tell me right quickly, if I find r at 0, replace the x's by 0, where's my y-intercept?
0.
0. That's what I want to hear. Get partial credit for that. That's done. Now, are there any vertical asymptotes? That's the question.
X equals.
If x is equal to what? 3. This is a crazy problem. Number 4.
Wait, how'd you get x is equal to 3 again?
Yeah, go to my denominator, set that denominator
Right.
equal to 0. That's all. Got 3. Woo! Do we have a hole on the graph also? That I have to be aware of. I think I pointed that out earlier. Horizontal asymptote, you cannot have a horizontal asymptote if you have an oblique. You cannot have both. So there is no horizontal asymptote to worry about on this one. I have an oblique. Guys, am I leaving anything out? I think that's enough. Intercept, vertical, oblique. There's a hole on the graph here, and let's see what this graph may look like. This is it. Here goes. Bear with me. Threw a lot at you tonight. I gotta stay on that grid. Gotta start placing things I need to place. We'll see what I can do here. Okay, guys, it's up to you, but I'm gonna place where are they? The x-intercepts first. So I got 0, 0. And also we found a 2, 0. What, 2? Another x-intercept. Those are done. Y-intercept, 0, 0. Vertical asymptote, we'll get that out of the way. It's over 3. That's here. There's my vertical. Jeez. Horizontal, none. Now let's put the oblique on there. I'll put them red. My oblique, slanted asymptote. All you gotta do is graph this for me. If you want to use the mx plus b, slope is 1, y-intercept is 1. From algebra, you can graph it. If you want to find the x and y-intercept of that quickly, you could. Anyone tell me where the x-intercept of this would be if I set this equal to 0 and solve it? Where's the x-intercept for x? Negative 1, thank you. So out here at negative 1, I will quickly mark this as my x-intercept on my oblique asymptote. Anyone tell me where the y-intercept would be if I replace x by 0?
1.
1. Okay, so let's go up to 1, show that. Plop that here. I did mine by intercept. You guys could do yours by a slope intercept form. You guys can do it free-handed. It's going to be a graph, a line, that looks like this. That's my oblique asymptote. I've already did my oblique cross over my vertical. Do you think that's okay?
No.
What's not supposed to cross over, ever? Cross over the vertical. The graph itself. Do I have the graph right now? No. So we're okay. As long as you don't have the graph to touch that vertical asymptote. Guys, am I leaving anything out? I got the vertical, I got the oblique, I got the intercepts. Oh, there's a hole on the graph. Where was it? Oh, it's here.
-2.
-2 down, what, 1 3/5?
Yeah.
So -2, I'll go out a little further. Now I got an issue. -2. I'm supposed to move down 1 3/5. Please tell me, this is strange. Is it going to drop down below the red? oblique, or is it gonna be above? It's gonna be in here somewhere or down here? How would you find out? Would be -2, if we have no mistakes, would be -2 down 1 3/5. Is all that calculation correct so far? How would you find out whether, when I plot it, show you where it is, the hole? Should it be below this red slant down here maybe? Or should it be right in there somewhere right on top of it? What do you think? How would you do it? Go for it, yes.
Plug -2 into the function for the.
I would, I'd find out R at -2. In fact, R at -2 is -8/5. So you say, no, Professor, now plug it into the what?
To the function of
To
the
the oblique.
oblique. Yeah.
Guys, if I replace x by -2/5 here, -2/5 plus 1 gives me what?
-1.
-2/5 plus 1 gives me 3/5.
Yeah.
Is that true? 3/5? Woo! Okay, I see what his thinking is. Guys, we've got to get this thing finished up. I'm just wondering if there's a hole on the graph, is it above here or is it down here? What do you think?
I think it's below.
Oh, it's the graph, it's the oblique asymptote drawn wrong. Which one is it?
Well, can't you just figure out more points for the oblique asymptote?
Do it again.
Just figure out more points for the oblique asymptote.
For the oblique
Yeah,
asymptote.
just like plug in, for example, another point that can give you, so, you can plug in, cause it's linear, so.
I'm just wondering where on earth is it working out for us? Or did Randy set you up? Is all that drawn correctly? Help me out. All I'm concerned about is where is a hole on the graph. Even before I get to the hole, let me do this for you. If this is all drawn correctly, by the way, guys, were these the intercepts? I think back there? Did we have the x and y intercepts plotted correctly? Was there a vertical at 3? Was there a vertical at 3? Oblique, I think I drew the oblique, yes.
I think it's below because if you draw the graph, the line there's only one line possible in between the block.
You mean in between here?
Yeah, so the hole can only be like on the line that we have points to graph, so it has to be below.
Okay, so she's saying, Professor, follow these asymptotes. She's saying, please, you gotta follow this asymptote.
Yeah.
Come up and pick up that x-intercept. So you guys are making that look like it follows that red. Then it's gonna pick that up and it's gonna cross over, I guess, and come over, and come back down, pick that up. Now, where's it headed now, if this is correct?
No.
Mr. Park. Guy, go ahead and graph this original, put it in the original form, and see what you get for the graphic shortly. You guys agree with that? I think it would have to look like that, as you described it. Now, be careful. I see another little piece of the graph that may be overlooked. There's another piece of the graph that we have not placed on here yet to finish it up. Where is it? Sometimes students will overlook it. Where is it? And I can always plot points, but where do you think it is? Is there another piece right here that would follow the asymptotes?
Yeah.
Up here in the corner. And you're talking about a workout. Wow. Mr. Park, how close are we?
It's quite close.
Is it quite close?
Mm-hmm.
Look something like that?
Mm-hmm.
There's the graph. First one you ever seen was an oblique asymptote. By long division. I'm looking at my time here. I got about 5 minutes before you guys have a break here. By the way, time has changed, right? They went and changed their time. So does that give me another hour with the class?
I don't think so.
Does it?
because-
I thought it would be another hour.
No, we have 25 minutes.
So we're not gonna end until like, we usually end at what, 7:25? So tonight I get to go to 8:25? Aiden, you ready for this?
Yeah.
Yeah, he's ready for it.
It says 7.
Okay, guys, I'm gonna accept this graph. And, oh, by the way, is there a hole on the graph?
Yeah,
Might it be, since looks like down here. You think it must be down here?
yeah, it has to be down there.
If that makes sense. Now, does that make sense, Mr. Park?
Mm-hmm.
Does that look pretty good?
Mm-hmm.
Okay. Tell the class, use your device there and find R at -2, no, at -2. Find R at -2. Just out of curiosity. See what the value is.
R at -2.
Find what R of -2 is.
What do I get undefined?
Yeah, because I set you up.
Yeah.
Why can he not, even on his beautiful AI information here, why can he not get an answer for R at -2? There's a hole there.